The final setup and CNC operation will be for milling the top profile of the car. So we can go ahead and hide this body and show the car body. In fact, actually, I'm going to retain this body here because I'm going to need to use this point here as my orientation point. And that's very critical because that's going to align the car body with the CNC origin. So we'll start a new setup. And we'll go ahead and correct our Z axis plane. And at this point, the bodies that we will be cutting will be, it's going to be the car body. So we'll go ahead and reselect the car body. And we want to see if it will move it. Okay. So now we have to maintain our origin from the same spot because that's the reference of how the machine locates the dowels. So it's critical that this be our origin. But that could be an issue for our tool touch off. So that is not going to work. We found a glitch in the X-carve that if we touch off to the bottom of the material, there's a glitch in the post that drops the tool into the material on its way out on the very final portion of the run. So I need this point to be up here to be on top of the material. It's not an issue at all on the ShopBot. So I'm going to need to match the size of this spoil board, but bring it up to the top here. So what I can do is come into the fixed size box, and I don't recall what the size is of this. So it's 3.75 by 7 inches. So I'm going to go back into setup. I'm going to have to redefine while it's still in my mind. That's 7. I'm going to say this is 3.75. And the height is 2 because our stock size, we didn't remove any stock from the previous block of foam, so it's still 2 inches. And it's giving me a default here. So what I'll do is, it's because both of these bodies are selected, and it's saying that the available material is smaller than the available bodies to be cut. So I'll remove the pre-selected bodies, come back and select the car body. And I'm also going to need to redefine the Z-plane. So once we correct the Z-plane, that should pop it back out. It doesn't look like, it looks like I got the correct width, but not the correct length. And we'll go ahead and we can set this point here. So for whatever reason, it reduced the width, which I'm calling the length, to 6 inches. So we'll go back and redefine that. And now we're exactly on top of the material. So that is looking good. Now I need to correct the location of the model relative to the box, because we milled this piece earlier with the bottom face directly in line with the bottom of the material. So right now it looks like it's cutting into the fixture board. So this is not on center. This is from the Z bottom, and it's at 0. Oh, so it's there. It's at 0. So now it moved that reference point of the material up to the correct spot. Okay, so that setup looks good. We'll minimize this branch here. So now we're going to use the same contour, 3D contour program as we had done before. And the tool we'll be using will be the ball mill. We'll be using the ball mill for everything. And it pre-populates these. So now we will select the model, and we want to select the entire model. There we go. The tool boundary now, we will select this outside profile. And just to see if it's going to populate it correctly, I'll say okay. We'll have a look at it. And that is cutting everywhere that I needed it to cut, but it looks like it's not coming all the way down here. So I'll go back into it and tinker with it a little bit. So I want to be, instead of on center, I want to be I want to be outside. Let's see if that corrects our boundary. There we go. So now it's coming down far enough with a slight amount of overlap to hit all of the points. So that should mill everything. Now, I noticed that the gap between these spots is really wide. And that's because it's such a steep or shallow drop off here that the depth that we've given it, which would be the default, 0.04, is taking really big steps down horizontally to get down to that 0.04. So we can, for a little bit nicer finish, we'll make this really small. We'll make this 0.01 as our maximum step down. Say okay. And it's still leaving a little bit here. We can sand that out, no problem. It'll have some ridges here. But for the most part, it's going to be pretty smooth, and it should cover everything we need it to cover. Just keeping in mind that all of this section here has already been milled out. So we'll go ahead and simulate it just to re-verify. And you can see those ridges. Now, if we really are particular about it, we can go back in and add another tool path going the opposite direction, and we'll clean all of that up. But it really adds a lot of time. That's kind of interesting that it leaves that there. And I do think we can clean that up. Also over here in the statistics, we can see the machine time. It says that it's 5 minutes. So that's not a very long machine time. So I'm going to come back in here into the contour, and in our passes, we have a directional cut. Maximum step down. Smoothing. So I thought there might be a way to modify the orientation of the cut. So we'll take a look at a 3D pass, a parallel pass. and it'll be essentially the same setup, except we'll have it go across this way. So we'll make sure that the ball mill is selected. We'll select our perimeter silhouette, and we want to make sure we select the body. I did not double check the height offsets, but that is in line with our material. It looks good. This path direction, the degrees, the angles that it goes in. So we can modify it to be any angle we want. And that's how we'll do the final cleanup. The step over, we want to keep this relatively small. We'll go 0.03. Let's see what the default direction is. So it's going in the opposite direction. So now when we run these two, I'll select both and I'll simulate. It should clean up pretty nicely. And again, for the foam, it's pretty easy to work with. You don't need to add that extra toolpath to clean it up. But if we were working with a hard material, like aluminum or even wood, we definitely want to clean these sections up, because it would be really difficult to sand those out. Also notice that if we were working with harder material, it's removing, even though it's only stepping down 0.01, it's removing a lot of material. So if we were cutting a harder material, we would need to run an adaptive clearing path beforehand to eat that material away. But for this purpose, with the foam, this looks pretty good. I didn't do the adaptive clearing here because it adds about 30 minutes of operating time, of runtime. And it's not necessary for the foam. It'll cut through it just fine. So it's a good point to save. In the next videos, we'll look at posting to the machines.